Today we're going to be looking at a failed TIPM that was sent from Ivan over at Pine Hollow out of Diagnostics. What you see on the bench here is actually one that I pulled from the junkyard to get a test setup ready, and pulled the connectors as well so I could get it hooked up and do a little bit of research. So I went ahead and printed out a list here of all the outputs that he had found failed in his video, and then what connection they're on, as well as this IC1 pin is referring to this output driver IC right here. I went ahead and buzzed it out and found out that all of these, except for the very last one, are connected to the high side outputs on that IC. I'm calling it IC1 because there's no silk screen, so that's just how I'm referring to it. So if you actually look at the data sheet here, that's actually, it's quad high side, octal low side. I'm not sure what the low side's used for, but that actually accounts for all the high side outputs for that IC. So when I got that far, I figured, okay, that IC has failed. Fine. But then when you get to the rear wiper output, it's a little interesting because that's actually driven by this smart switch IC right here. It's just a single high side switch. So I don't know if it failed at the same time. If it did, this might get a little bit interesting. So I have it set up here to be able to command the outputs on with the scan tool. It's actually simpler to get this running on the bench than I expected. So I have a DLC here pulled from a car. Here's can high, can low. And I was going to put a termination resistor in here, but there's actually a 60 ohm termination on the input of this module. This is actually, if you look at the network diagram, this bus is just straight to the DLC. That's all it is. So this is the gateway for the rest of the network between the scan tool and the rest of the network. Let's see here. So I took those outputs and I brought them out to this terminal block here, so that we can measure them all without having bare wire shorting together. So I did a little digging and saw that, if I can get to it here. Have to edit this out. Saw that this V power here is pretty much directly connected, or at least it measures it dead short, directly connected to this battery input post here, which is a little alarming since there are no fuses left in the device. Granted, this does have short circuit protection and all that in this device, but if this actual output device in this FET fails short, I don't really like what condition that leaves this in. Anyway, that being said, for the outputs that are on this IC, we should be able to see this, the body diode. We should be able to see the drop to the power and battery power input. So that can be a quick check on the failed device that'll tell us right away. I mean, if we see open here or we see 0 volts, we know with the device unpowered, we should know that we have a failure in the output. We don't have any kind of problem with the logic that's driving this IC, which is kind of interesting because we actually have the option to use a SPI driver, or they have discrete inputs depending on how you initially configure it over SPI. So I haven't gone far enough to see exactly how they're driving it, but I think first off we can get a good idea of how if the output has failed from that. We can we can do a bidirectional test here and verify that they're actually not functional. Then for the rear wiper output, like I said, is on this switch here, and the power input that's switching is not directly tied to the battery input. It's switched somewhere else on the board. But once we get it apart, you can actually, I checked, and you can actually see the body diode from the output to the tab, which makes sense. Okay, so I'll get the device that was sent in set up, and I'll get back to you. Okay, before we move on to the device that was sent in, let me just demonstrate these checks here to show you that this setup is working. So first of all, we'll just we'll check the body diodes. So I have that in the first output on this terminal block, which I have them set up in the terminal block in this order, so that's the right low beam. Anyway, so we'll go to the battery post with the negative output here, and you see we have 0.54 volts drop here. Okay, so that is the same for all the rest of them that are on that same IC. And then we'll go to the rear wiper, if I can line this up one-handed. It's this one. And then we can go to the tab on this switch here. And you see 0.5 volts. If I can hold it right. All right. Now, let's bring the scan tool in, power up the module. Go to Dodge. (16-pin) Dodge again for some reason. 2010 caliber. System selection. We'll go down to BCM, they're calling it on the list. And something I found that's interesting is the low beams. So this is the right low beam. The low beams are on to begin with, which I don't know, maybe it's just defaulting to that because it doesn't have an input from the headlight switch. That might make sense. See if I can get this to stay in here so I can show you and get it in the shot. Alright, so we'll go to actuation test. Sorry for the power supply noise. And we'll go to right low beam, and you'll see when the test starts it actually turns it off. Okay, and then back on. So we'll hit off, goes off, on, goes on, times out after a bit. So I did check all the other outputs and I am able to control them this way. So now we will set up the other unit. Alright, it's been a long time since the last segment here, but trying to figure out how to get a good shot of actually working on this thing and taking measurements, and got a little bit of work to do there still. But we have the unit that was sent in on the bench. I've actually found the fault and repaired it. I reversed the repair so we can kind of walk through it here. So first thing I did, like I discussed before, I checked from all the high side outputs on this IC in question here to the battery post, check for the body diode drop, and I did see that. As well, I also saw that on the rear wiper, the discrete switch for the rear wiper output. So, I mean, that doesn't guarantee that we don't have a problem with the output FETs, but it kind of leads you away from that. So that was kind of interesting. So I went ahead and started looking at, okay, what signals do we need for this IC to run? So started going through them. We had, get to another page. So here's actually the whole pin diagram. So we had VDD, which is like the logic level power supply. I believe it was 5 volts on this. We had V power here. This is going to be interesting later. We had V power here, which you can measure on these. Where is it? On these vias right here on the bottom of the board. This whole plane is actually connected to the V power input. And I just lost my ignition switch here. Okay. So we had power and ground on the chip. So then I looked at these. So we have, this is the SPI bus here. So we have the chip select, clock, and serial input, and we have the serial output over here. And they all had, reasonable signals on them. They look fine. That's not guaranteeing that the actual data that's being sent over is telling it to turn on the outputs that you expect it to. I also verified, as we discussed before, you can have discrete inputs, and here's some of them here for the high side outs as well. These are actually all tied together and tied to ground, so those aren't being used. It's all being done over SPI. So I started going through here. The reset's high. That's good, so it's not being held in reset. There were a couple more like these wake and watchdog input. So I kind of read further in the data sheet what we should see there. Everything looked fine. I will say on the watchdog input, I expected to see some kind of strobe signal coming from the micro to here to prevent the watchdog from kicking. So I saw nothing there, but reading further into the data sheet, that can be done by setting a bit and a register over SPI. So at that point, it's kind of weird. Body diodes look fine, but I had kind of figured, well, looks like we have everything we need. This chip is probably bad and needs to be replaced. The problem with that is this is obsolete and it's not available from any reputable suppliers. There's like onesie twosies on eBay here and there you can get. So I kind of took another look at it and made sure, do we really have everything? So I started going through the pinout here, and so just marking down measurements. So we have VDDs, here's like the serial bus and reset, and just writing. So here I saw 5 volts, 5 volts, 5 volts, 0, G for a good signal on the data pins, and VDD is 5 volts. So when I got to, so I had measured V power before, but I just measured it on the bottom of this pad. This time I actually went to pin 2 and took a measurement, and I saw about 5 volts, which I thought was very interesting. So reading into the data sheet further, it tells you that this V power pad here and this V power pad on pin 2 must be shorted together on the PCB. It doesn't tell you why. It really doesn't give any details. There's not a lot of details in the block diagram. It looks like all the V power stuff is just shorted together. So we have, the nice thing here is we have 2 of these ICs. We have one here, and we have one here for more outputs. And I also have another board that is working. So I was able to find out that this pin 2 on these boards actually has I think it was about 2.4 ohms of resistance between that pin and this V power plane. As well as, I actually think, the main battery input. I think it's basically directly connected to that. But on this IC here, on this board at pin 2, it's basically, it was open. So, and let me show you something interesting else I found right after I saw that 5 volts on that V power signal. Turn on the power supply here. Look at the test light. So this is the right low beam output, and that's the one that we found was on by default with this condition. So on the other board, this just turns on when there's power applied and you have the ignition. So something interesting, if you can, I don't know how well the scope is in shot, but that's going to make a lighter out of me. It's not doing it. Thought there would be 5 volts there. Let me check the, so let me probe V power. Yeah, we see it's slightly under 5 volts. And then something interesting you see. So when you probe the output, okay, this is interesting. It's not commanding the output on right now, clearly. Do we have a connection problem? No, our current looks normal too. Let me go in on the scan tool and command this output on. Sorry for the delay. TIPM. It's processing. Okay, Actuation test. Oh, it already popped on here when we started communicating. Okay, so this is. Oh, now it's off. Let me go. It's behaving rather weirdly. So this is right low beam. Okay, I just went into the test and now it's on and now it's off. Okay. Hit on. Something strange is happening with it now. Sometimes it's... Okay, now we have 5 volts. Let me command the output on again. This is interesting. Let's see the output. Okay, well it's acting differently now, but just explain before. So this low beam output seems to be on by default. I don't know if it's because it's not seeing the input from the headlight switch, and that's the default strategy. I'm not sure, but for the most part, till right now it's been on by default. But I mean, I could be due to this fault that it's not. But so here's our V power on pin 2, slightly lower than 5 volts. So what I had seen before is there was that same voltage on that output for the low beams, and then when you probe it with a test light, it would basically pull it to 0 and then pull the V power on pin 2 to 0 as well. Okay? So, like I said, I found that there was 2.4, 2.5 ohms between, there should be on a working board between pin 2 and V power plane. So I went over the entire, on the second unit I have here that's working, I went over the entire board with the continuity beeper on the multimeter and a brush here. And I did not find anything that was lower resistance to pin 2 than the V power plane. So I don't know where that connection goes. And if you just look up around the via, like in a light, I don't see a trace on the inner layer. So I'm kind of wondering if it's actually an internal connection between that huge thermal pad for V power and pin 2, but they also want you to short it on the board. And I'm thinking that's what the case is, and the designers didn't do that. And something might be open in the IC. I'm not positive of that at this point, but I think in the next video we'll take one of the ICs off the other board and we'll find that out for sure. So, being that it's not commanding the output, the low beam output on right now, this might be anticlimactic, but what I did for the first step is, so the V power on pin 2, I went to the decoupling cap on the other output IC, and then I basically used a fuse jumper wire to short it to pin 2 on the IC in question. And by basically a fuse jumper wire, I mean I have it in the milliamp microamp input on my fluke here, and there should be, I think it's like 400 milliamp fuse in here, so if that's a really bad idea, it should blow the fuse. So let's try that again. And when I did this before, it actually lit the test light because it had this output command it on, but it looks like that's not going to happen right now. And it does happen. You can see the test light is lit. Okay. I'll try to do this. I'm holding that with one hand. You can see our output is on. Turn our output off. Yeah, so this is on there. It just turned up there. It says off, and the test light is off. Okay, and then it times out and it goes back to on. Okay, so it appears that it is working now. Okay. So the next step I did, like I said, I couldn't figure out exactly where that was supposed to be connected to, and I actually am suspecting that it's not connected to anywhere. So this actually still might be an IC failure, but it does seem to work if you connect it to V power. So what I did is there's a via right next to the decoupling cap that hooks up to pin 2. And where is it? Right here. So right next to it, you're not going to be able to see it at all in this shot. But right next to it is the V power plane that goes to this main big thermal pad on this output IC. So I just scraped back a little bit of the solder mask on the plane, and then there's a test pad for that via right on the bottom of the board right next to it. So I just scraped back and I just put a little solder bridge between that test point and that plane, and then seemed like all was right with the world. I'll try to do that again. I should have had my soldering iron hot for this video. I'll try to fix it again real quick. Oh, well, that's heating up. What I did not mention is that so these are output pins, high side 0 through 3. So these are all the high side outputs on the chip we've been discussing. Now the rear wiper output also does not work. And I thought it was very strange that those things weren't related. Like I said, the body dial looked fine on the driver for the rear wiper. I actually measured a pin 2 on here should be pulled to ground to turn this output on. Pin 2 on this output FET. It's actually a smart switch. On the smart switch, this output for the rear wiper. So I actually was commanding it on, monitoring that input signal with the scope, and I never saw it pull to ground. So use the beeper on the multimeter, continuity beeper on the multimeter again. I found out that it's actually connected to one of the low side switches on this IC we were just talking about that I was wondering what they did. So at least one of them is actually being used to drive other high side switches with their own discrete smart switch. So I'll show you that in a minute, but actually this one fault caused all those outputs not to work, and once it's restored, they all work. So soldering iron should be hot. Let me see if I can do this real quick on camera. Okay, see a little bridge there. Everything's still connected. Got our ground. Get this out of the way. Bring this in shot. Okay, I'll take one of these probes from the multimeter and we'll just stick it in here. So Put our test light on that, which is out of shot. And we just lost our ground. And our ignition. Okay, now I believe when I turn on the power supply, that test light will light. There it is. A little bit of a delay, but it lit. Okay, now let's go through on our scan tool, and it's lost communication, so I have to go through all this again. So we already know that the right low beam is working. Let me just move on to another one. So this will be the left high beam. So I still gotta go in here, Dodge, 2010, caliber, system selection, BCM they're calling it. Takes a little while. Okay. Actuation test. What did we say? We said looking for left high beam. Left high beam. Turn it on. Test light's lit. Turn it off. Wait, there's quite a delay. Our test light's out. There's a huge delay in it telling me the value is on and off on the data on here. Okay, now we're gonna move on down the line to the left rear turn signal. That'll be the next pin. Left rear turn lamp, it says on here. And then we'll turn it on. And it's on, the light is on, we'll turn it off. And the light is off. Okay, move on down the line again. We have right front turn signal. Okay, right front turn lamp on the list. Turn it on, lights on, turn it off, light is off. And last but not least, we have the rear wipe. It's actually rear eye wipe on the bottom there. I don't know what that means, but that's actually the output there. So we'll turn it on, test light lights, turn it off, test lights off. Okay, turn off the power supply, get that noise out here. So, also the scope. So that, I mean, I think we can call this a fix. I think it works. I'm guessing that I'm guessing that those two V-power pins needed to be connected on this board, and they were not, and that might be leading to a premature failure. I don't have all the details on that, and I haven't 100% verified that. What I will do, and probably split this up into another video, is I'll take this other board, which I've already brushed most of the conformal coating off. And I'll use hot air and I'll take one of these ICs off here. And we'll measure the pads on the bottom and see if we see 2.4 ohms between the two, and with the IC off if we see no connection on the board anymore. So I think that's all for this one. Thanks for watching.